so there was this summer thing that was happening. And so I had a tech who was running all this group, and they're doing all this wireless and stuff. And so she was using these illegal bands when the June 15th or whatever crossover happened. And so she goes and she sets up this show, and she does the sound check, and everything's working well, and she goes through all the wireless, and they're all working nicely, and then people start to come into the venue, and they start to pull out their phones and stuff. And so all of a sudden the show's happening, and there's all kinds of interference. And anytime somebody gets like a notification on their phone or a text message or something, there's some interference that happens.
Get the nice like sound of data transferring.
Yeah. And so because there's a wireless carrier that bought that 600 band. So anyways, she was like complaining about it, and I was like, that's because it's illegal now, and you're not supposed to be using that band. So you need different wireless, but it's a real thing. And it's, there's like big FCC fines too for that.
Yeah. Oh yeah.
So. You're listening to the GWNL Podcast. Guys with no lives talking about audio.
Hello and welcome to episode 18. We are talking about wonderful podcast stuff. We are GWNL Podcast, guys with no lives, talking about audio. And this week we're talking about wireless and networked audio, which is a hot topic in the sound world, I would say.
Yes, especially live sound, which is why Joe is super excited for today.
I did some things with RF once, I guess.
Once?
A number of times. I complain at work constantly about not having proper antenna combiners and not using stupid quarter wave antenna whips in racks. Like, sorry, look, nobody in the audience understands this, but now I'm bitter.
Yeah,
like,
we got him going.
I shouldn't do this because now I know people at my work actually listen to this podcast because they were listening to it like while they're working. Like, I shouldn't do this,
man.
but like.
Yeah.
The insanity of using quarter wave whips next to power cables is stupid. Like, that's how you get interference, if you were curious. Anyways, long story short, I'm bitter about it. I ordered it in a year ago, and nothing has arrived, and nobody's ordered anything. Wireless audio. What makes up wireless audio? Who wants to take the first step?
I was going to... Can I jump in real quick before...
Yeah, let's go.
Then we'll have Bryant do it. But I want to... Joe and I were talking about this the other day about, people learning to do a professional level. And I think we have in our culture and society right now, there's this concept of I can just learn everything I want from YouTube. And, before that, it was I can learn everything from books. And I think wireless audio is one of those things where you get a lot of people that, okay, I get a wireless transmitter and receiver, wireless mic or whatever. And they're like, oh, if I just repeat that and get more of those units, they figure it out themselves.
Stack them on each other.
Yeah. But there's this other so that's like the prosumer self-taught sort of thing. And then there's the other concept, which is you're like learning from professionals. And there's this benefit of learning from a professional and learning how professionals do it. And in wireless audio, it's one of those things that you have to learn from a professional because it will like crash and burn catastrophically if you don't learn it if you just kind of do this do-it-yourself sort of thing. And so there's a lot of things that will work on the do-it-yourself thing, especially if you're only getting to a certain level. But if you're trying to deal with a bunch of RF, you got a bunch of IEMs, and you got a bunch of wireless mics, it's just like total crash and burn if you're not doing it as a professional.
Also, I had an issue recently where I had to tell one of my coworkers, good guy, I was like, hey, so you're using an illegal wireless transmitter for your pack. We can't use that. And he was like, what? And I was like, yeah, no, this is illegal. And he's like, what? I was like, yeah, FCC sold these frequencies. That is in those frequencies. That's not allowed anymore. So like when you were saying, Ben, about like knowing the things, that's because there are FCC regulations that you have to abide by when utilizing these wireless networks, because you're not just talking about interacting with just your own networks or someone's cell phone networks. You're not going to affect cell phones usually unless you get too close to systems.
They'll affect you though.
Yeah.
Had that
but
happen.
you're also affecting things like TV stations if you don't know what you're doing, and other radio stations if you don't know what you're doing. And let's get into more important things like emergency broadcast systems. And you think, oh, I'm not in the same frequency range. Well, there's this thing called gain. That's your friend and your enemy. But we'll get into that later.
So let's hand it over to Bryant so he can. I'm sorry I cut you
Say
off. I just
something.
wanted to put that
No, you're good.
out there. Yeah. So
Yeah, so in wireless audio, basically you just add a transmitter and a receiver. You have no more cables going between your microphone and the receiver.
I can't.
What do you do?
No.
Anyway,
I got it.
there you go.
Anyway, basically,
Yeah,
so in audio, you've got transducers. So you've got your microphone that then goes, has a capsule in it that then converts the SPL into voltage, that then goes into a preamp, that then goes out through another transducer that converts that voltage back into SPL, and that's your speaker. Wireless audio adds in converts that voltage into radio frequency, basically, to then be transmitted to a receiver to be received, and then converted back into voltage to then be converted back into SPL.
So it's just So long story short, it's just instead of a wire, you have a gap in the wire where the sound is going over light waves, over radio frequencies.
Radio waves, not light waves. Those are different waves.
And they're
Same,
still
but different.
They are, yeah.
We
Radio
use
waves
IR
are
to
light
sync
waves.
things.
No, radio is light.
No, light is radio. There's a difference. Electromagnetics. I don't want to get into this.
Anyway, something that's kind of becoming more popular is digital wireless equipment, and basically all the digital side of it does is there is an analog to digital converter within that will then convert the voltage to ones and zeros, and then it'll convert into radio frequency, because it's a lot easier to transmit ones and zeros than
It's
a
also
complex
much more
wave.
stable.
Yeah. So you get basically with digital wireless, it's essentially the same thing as like an analog, quote unquote analog wireless, but you just have the digital to the analog to digital converter and then the digital to analog converter.
And the reason it's more stable is because it's simpler to transmit ones and zeros, and it is simpler to check for errors when transmitting that kind of information versus just transmitting an analog signal. That's one of the reasons why digital tends to be more stable and less like interference with the actual audio signal.
Yeah, and the errors that will occur, there's already error correction in place to deal with those kind of things. Whereas in a regular analog audio, the errors that occur equate to noise and messing
like
up
fuzz,
with, frequency
harmonics,
response and things like that.
Artifacts.
Yeah.
There's a term that I'm thinking of, but I can't remember what it means, but companding. Is that what it is?
Oh, I think so. Companding? I'm pretty sure. Give me 1 second. It's been a while since I've had to really
He's
think about that.
Googling it.
I have to.
I remember that
in
being an important
telecommunication.
term.
Companionship is a method of mitigating the detrimental effects of a channel with limited dynamic range. This is from Wikipedia, so it's nothing crazy. In telecommunication and signal processing, companding is a method of mitigating the detrimental effects of a channel with limited dynamic range. The name is a portmanteau of the words compressing and expanding, which are the functions of a compander at the transmitting and receiving end, respectively. So, can I take a moment to explain the difference between AM versus FM?
Yeah, as I say,
that's-
that seems it applies to AM, FM.
So imagine, I read this off of Reddit, so I can't take full. I think this is the best explanation for explaining how AM versus FM works. AM stands for amplitude modulation, and FM stands for frequency modulation. So the way somebody described it on Reddit in a great post on the R Live Sound Reddit was, he's like, imagine you have a friend in the neighborhood over, but if you yell to him, he can't exactly understand the words that you're saying. So you figure it out. You can either, you can yell louder and softer, and when he hears you yell louder, and he can hear you softer, and he can hear you louder, but he can't tell you what you're saying. So you realize you can yell louder and softer and louder and softer, and if you do that in a proper sequence, you can do Morse code and other things like that. That's amplitude modulation, because you're modulating the amplitude or loudness in this instance, or essentially the amplitude of the frequency. Well, the difference between that And frequency modulation is you try that, but sometimes with the lower frequency, the lower loudness, it's really kind of hard to hear some of the lower volume stuff on the amplitude. So you try, well, instead of like louder or whatever, you try. I was actually doing frequency modulation there. Pretend like I wasn't doing that, but he says, why don't I try changing pitches instead of that? So like and you're yelling at the same volume, but you're changing the pitch that you're yelling at, right? And he's like, oh, I can hear everything he's saying, blah blah blah. It's really easy. So FM, frequency modulation, is where they modulate the frequency of that, essentially cycle.
Bass frequency.
Yeah, whatever it is.
Yeah, they take a high frequency and modulate it by the content.
Outside of the realm of human hearing.
Yeah. And then all
Very
you're doing
outside.
is sending that one modulating frequency, and it's actually sending all the content that's in our human range of hearing. So instead of sending...
We're using frequencies to send frequencies so that we can hear frequencies from things that translate not frequencies to frequencies.
And the frequency of him saying the word frequency is starting to drive me crazy.
Okay. Anyways, should we go on to the role of antennas? This is actually something that a lot of people overlook when they're thinking of getting wireless.
And
they
this
think,
is it's part of that professional versus prosumer.
That's why I'm so mad
do-it-yourself
about no
thing.
antenna combiners at home.
I have like multiple conversations every week with people where they call in. They're like, "Hey, so I'm a part of a church. We're replacing some of our wireless equipment. We have 8 channels of wireless, and we want to get this, we want to get this 2.4 gigahertz system." And it's like, yeah, that's probably not going to like go over very well with you, because the 2.4 gigahertz systems, really, you're looking at maximum of 4 total if you can get them all to work together.
Also, that's also a Wi-Fi network frequency range that they use for
Yeah,
Wi-Fi.
that's true.
Yep. And so then you have to have the conversation of like, okay, well, let's get you into like a UHF system. And then you're like, okay, what are you doing for your antenna? And they're like, antenna, we just use the ones that come with it. You're like, well, let's talk about interfrequency modulation. So anyway, Joe, take it away.
So intermodulation is the concept of where you have essentially a fundamental pitch, and there are certain frequencies. Was it first order, second order, and third order octaves, or first octave, second? So it's simpler in like harmonics when we think about like music, because if you play a fundamental pitch, let's say it's 100 hertz, you know that you're also going to have a pitch that occurs at 200 hertz, exactly double that pitch, right? That's the octave in theory. And then from there, it starts to break up and divvy up into smaller and smaller fragments of
It's all
that.
it's all the ratios of the whole. So
I don't know
there's
the ratios.
There's a 2-to-1 ratio for that first. There's a 3-to-1 ratio, so 300 hertz, which is an octave and a fifth. A 4-to-1 ratio is 2 octaves. There'd be a 5-to-1 ratio. So that's happening in all frequency-related things. There's going to be harmonics that happen, and so you've got. That's what you guys are saying, right? That there's you have the frequency that's happening, and then there's the harmonics that are gonna
Occur.
vibrating and stuff.
One of my favorite like analogies for it is like a piano. Basically, like for people to really understand like for interfrequency modulation, if you have a piano and you have like the damper pedal down, so all the strings are open, and you press one note, not just those strings that are tied to that one note are going to vibrate. There's going to be other strings that vibrate sympathetically with that, and
Sympathetic vibration.
Basically, as you add more wireless channels, those radio frequency harmonics get like worse and worse.
Let me add to that. When you add lots of wireless channels in close proximity, this is where those things. So if you've never done this with a wireless microphone before, you should try it. It doesn't matter, and this gets into more RF stuff. So intermodulation is partially the harmonics that you're creating from the transmitter that's out there, but also the location and the distance and how frequencies are managed for those wireless units. So intermodulation is both the harmonics, like the first octave, as well as second order, third order, and fourth order harmonics, as well as being close to it, like you were saying with the sympathetic vibrations of the piano. So The reason that this is important is a lot of times, so why I was angry about not having an antenna combiner with my wireless at work, I have a bunch of what they call quarter wave antennas. That means I'm only the length of a quarter of the wave of the frequency that I am transmitting and receiving on. I have 8 units in one rack, all next to each other, all next to power cables. Quarter wave antennas, and you're thinking, okay, what's the big deal? Well, here's the problem. I'm getting electromagnetic interference from the power cables. I'm getting electromagnetic interference from the wireless antennas. And when I say interference, anything that happens from one transmitter to another is going to be picked up by all the antennas. But what the wireless receiver does is it says, oh, everything outside of this range doesn't matter. I will not care. That's what happens when essentially with a receiver. So intermodulation, where you're talking with the sympathetic piano strings, if I have this wireless unit here and this one right under it in a rack, and there's an antenna sticking up right next to the other antenna, and I have a microphone close to those antennas, even though that microphone may be tuned to a completely different frequency, because that frequency and how close that transmitting microphone is to those antennas means those antennas will pick up the signal from that microphone transmitter. Regardless of the frequency there, it will overpower those receivers. And so this is why intermodulation becomes a bigger and bigger issue the more and more wireless you deal with, and why you need things like antenna combiners when you're dealing with more than, I would say, it's hard to say. Like, I feel like 8, like 4 to 8, anything above 8,
really,
you need a combiner. Like,
really anything above 4, you should
that's what
look at a
okay,
combiner.
thank you. I felt 4.
When people start talking about, getting 4, that's when I have the conversation of, okay, like you really need to get some sort of antenna distribution or antenna combining solution here.
Combining and power distribution.
Yeah. And there's some really cool options as far as like product stuff goes. I don't want to do a huge plug on companies, but there's a company that is basically their whole thing is just RF solutions. They don't even sell the microphones, the transmitters and receivers. They just sell all the solutions to make everything work together. So,
which can be really nice because there are a lot of places that don't have the money to afford to buy all the same thing all at once, and so it can make a lot of problems not problems.
Yeah. And the thing also something to talk about with wireless audio is that you may be maybe you have an installed location and your wireless equipment could be working one day and the next day you come in and it's not working at all because our RF is constantly changing around us and evolving, and the kind of band that we have to work with within ultra high frequencies or UHF band is constantly getting shortened by the FCC. It's kind of I guess, a first world problem that we have here in the States.
Yeah. And that I want to tell a story that kind of applies to that. I mean, first of all, I've been in the audio industry for 20 years, and I think we've had to change 3 times in the last 20 years.
That's expensive, man.
Yeah. So, and it's funny because the second to last time they changed, it was we'll just jump up to the 600 band because they're never going to use that. And so I remember all the things that was all everybody's rationale. And then they just took that away 3 years ago. 3, 4 years ago.
Yeah.
It was 3 years ago this summer. So, it was 2019, summer of 2019.
I remember it like it was yesterday.
So anyways, but the interesting thing that happened, well, first of all, they give you, a lot of the manufacturers will give you trade-in deals and stuff like that. Mm-hmm. But with us, with the school, we had all this wireless that was in the illegal bands. And there was, so there was this summer thing that was happening. And so I had a tech who was running all this group, and they're doing all this wireless and stuff. And so she was using these illegal bands when the June 15th or whatever crossover happened. And so she goes and she sets up this show, and she does the sound check, and everything's working well, and she goes through all the wireless, and they're all working nicely, and then people start to come into the venue, and they start to pull out their phones and stuff. And so all of a sudden the show's happening and there's all kinds of interference. And anytime somebody gets a notification on their phone or a text message or something, there's some interference that happens.
Get the nice sound of data transferring.
Yeah. And so because there's a there's a wireless carrier that bought that 600 band. So anyways, she was like complaining about it, and I was like, that's because it's illegal now and you're not supposed to be using that band. So you need different wireless, but it's a real thing, and it's there's like big FCC fines too for that.
Yeah.
Oh yeah.
So with that, I would like to take a moment to talk about like different types of antennas that are used and general uses for them. So you have quarter wave, you have half wave. We called them whips, but they're just antennas. Like you have quarter wave, which is the length of a quarter wave. You have a half wave, which is the length of half that wave. Then from there, you get into more complicated. And these are usually used in conjunction with antenna combiners. Things like you might see the shore. We call them shark fins is what they are. Yeah, you have shark fins, paddles. Sennheiser usually uses like the paddle style ones, which, I mean, Google them. And then you have, those are pretty standard ones, and they're going to have a general like direction. There are some that have like what they call diversity fins that have more of a wider range of acceptance for receiving or transmitting frequencies.
The cool ones that I really like are like the dipole, where it's if you look at like a diversity fin that's dipole, it actually has two
orientations.
Two inputs, because really to get like the best results on any like wireless equipment, you're gonna have two antenna.
And you'll see that
channel.
on all the receivers. There's like two antenna, and there's a reason for that. That's what you're going to say, right?
Yeah. And so with the with like a dipole diversity antenna, when it sends its signal, it's sending its signal, on a oh gosh, how do I say it in words?
Axis?
Basically, you have two different
axis.
You have two different axes that it's sending it on versus just one. And so you have like kind of like your X, your Y axis that it's transmitting on, and then also your X axis to really like get the best pickup pattern that you can with a directional antenna. Does that all make sense?
Yes. Sorry, I was just messaging somebody from work about some stuff.
No, yeah. And I think part
Yeah.
of the reason why there's the two is so that they can, it's like it receives the signal.
If one's not working well, they'll switch to the B antenna. If A's not doing well, B will be the used one, and vice versa.
And part of that is if somebody has a handheld microphone and they're moving around, it may be getting good signal from the like X-axis antenna, and then when they like move it closer to their mouth or they flip the orientation of it in some way, it may not be picking up on that antenna very well, and so it'll swap over to the other antenna that's on the other axis.
Right. So now I'm getting into more complicated, or I guess more specialized kinds of ones. You have like helical antennas, which function much with the way that think of like a shotgun microphone, how it's got a more pronounced forward polarity pattern. The helical is designed specifically for those things. You'll see them a lot at like football games where they use them to cover across the field to make sure that they're kind of used like boom mics on like movie sets where they'll cover the ref. If you're at an arena or like at a football venue or some type of venue like that, you'll see those often because they're trying to shoot across a field in a more directional pattern. The other one I'm trying to remember, dome antennas, I think is what it is the other one. And it's just a dome. That's all it is. I think it is it helicals or domes? I think domes are the better ones for IEMs.
Helical. You'll see helical for IEMs. Those are the most common ones. Dome patterns are really good for kind of just like, they're really good for like trade shows, or like conventions where you'll have a bunch of different booths and you really have to like coordinate your frequencies. But because the like dome is so powerful within its range, you don't really have to worry about neighboring people with those.
Can we wrap up with RF with that kind of point, with coordinating your frequencies? Because that's I think that's one of the most important concepts. I know that we can go. There's all kinds of crazy things, but I think to wrap it up, there's a couple software programs that will help you to coordinate the frequencies. I mean, I was doing sound for a festival, and we had the sound lady from the other side, who was managing all the RF over there, came over and we were like two ends of the street, and so they would have an act go, and then we would have an act go while they're setting up the next one anyways. So we're like quarter mile apart, but still close enough to, or maybe it was a tenth of a mile, anyways, a block. Anyways, she came by and she was like figuring out all the frequencies and going through and making sure that we're coordinated so that, you know, not only do you have to coordinate your frequencies that you're using and all the stuff, if your guitarist and your bass player have their own RF packs, and then you got all your wireless mics and then the in-ear monitors, the IEMs, but then somebody else who's close by, you've got to coordinate all that. And there is software to do that, to kind of scan the RF and see what's happening.
You have Shure Wireless Workbench, and you have Sennheiser's Workshop Wireless Manager, I think is what it is. SWM.
Yeah, those are the two main ones.
And then Audio-Technica has one that's proprietary to like their equipment as well that works really well with their stuff.
There are also some, and I'll point this out. I know because I work with a guy who's an RF technician. He actually hates Wireless Workbench, which is kind of funny. But the reason, anyways, long story short, there are also other third-party things that are more powerful for coordinating larger volumes of wireless networks and not wireless networks, but wireless frequencies. That's kind of outside of the realm of what we're talking about today, and I don't want to get into that because it's a whole nother rabbit hole. But know that there is more than just Wireless Workbench and Sennheiser Wireless Manager.
But it's a thing, you know, that's the big thing is that, and there's benefits with even like the digital wireless and the networked wireless, because then you can manage the RF over the network with them too. And
yes,
there's all kinds
even these days you can just run like all of your stuff through Ethernet, which is a great transition into our second half of today, which is networked audio.
Yeah.
Wow, was that what you're trying to do, Ben?
Yeah, sure. That's exactly
Great transition.
Yeah, I know, right? That's what they pay me the big bucks. No, so like we have a bunch of different what I would refer to as protocols for networked audio, and I think there's also multiple use cases for this too. With networked audio, and it can be very convenient. It can also be a pain in the neck. It's fairly scalable, and it can be very useful if you have the equipment for it. It can also be a pain in the neck.
Some of them are scalable. Some of them are not.
Can I get us started on this, Joseph?
Go for it.
Bryant?
I suppose.
Well, no, I wanted to talk about just networking in general, like the concept. Like I think most people understand it and don't quite understand it all at the same time. But the benefit of networking versus just like point-to-point connection, like with like a USB cable that's going from your printer to your computer versus networking your computer and your printer, like the USB cable is just sending signal either there or sending signal back. And it's like receiving that signal or sending it off or whatever. Whereas networking, it's like these two devices that are communicating with each other. And and that's what the internet is, just a whole bunch of network computers, you know? And I think I explain that to students and they're just like mind blown. It's like it's not like some like secret layer or something. It's like all of our computers network together, and you can just take any computer and host a website on your computer and make it available to everybody else. And now you're part of the internet, the web. That's why it's called the web. So network in audio, they've been trying to do this for a while, and they even Yamaha tried to do one over
That's why they bought into Dante.
Well, anyways. They tried to do one like over a Firewire protocol. Back in like it was like 2001 or something like that, and they tried to push this one, and it was a networked audio sort of thing, but it was over Firewire, and it didn't last very long. But then, since then, they've come out with all these different protocols for networking audio, and it's not just audio; it's like visual too. So they have AVB, which is one of the standard ones, and you're not only doing audio but video. It's audio video bridge, but there's a whole bunch of other ones. So
and then Dante also does video.
Yeah,
and that's why Audinate created Dante, which stands for Digital Audio Network through Ethernet, but it also does video, and so you can I forget how much video you can. I think you can have like 2 video tracks over Ethernet with that.
Yeah, but what quality video? That's another big question too, because that's like saying, oh, you can have 2 tracks at like, 8-bit audio at like, 22 kilohertz or something.
I think it was, if I remember from the certification, I think it was 1080p.
Okay,
that makes sense.
I don't think it was 4K.
HD. Yeah, probably not.
See, and I feel like that's going to kind of fall flat for a lot of like professional video stuff, because 1080p was the sexy thing, and now it's like 8K so that they can scale things down and get better.
Yeah, but when they're doing a
choices.
video system, they want to keep it separate than the audio system. I think having them together is more for, it's kind of like HDMI carrying both video and audio, where it's like you've got presentation things, and we're going to network these together and send both video and audio. But if you're doing like a video wall and then you've got your sound crew doing a whole sound system, they're going to be totally different systems. Yeah. So
And video wall as a whole,
but
man, that's a mess.
As far as the different protocols go, though, AVB is more of like an open source, like open domain, and so devices, different AVB enabled devices may not play well together, which is why Dante is kind of a cool thing, because it's so regulated by Audinate. They have to source their Dante chips from Audinate and get certain ones manufactured. Basically, any Dante enabled device is going to work with another Dante enabled device.
I will say this, and that's one of the reasons why I'm kind of a big proponent for Dante more so now, is because it's got a lot more cross compatibility. I ran into a situation where I use Allen and Heath boards at work, and I was working with another ensemble that uses like Yamaha boards, and we had this situation where we were trying to figure out, oh man, we really don't know how to split up the stage, because their band was going to come on and do their set, and then my band was going to come on, and they were going to flip flop like a kind of a battle of the bands thing. And we're like, crud, how are we going to like handle this? Like, do we duplicate the patches? Like, what we're going to do? And he's like, well, do you have Dante? You could just send all that signal to me on my Yamaha board, and then I could just control it from my board that I'm familiar with, and you could run on your Allen and Heath board. And as because we're just switching, then we don't even have to switch boards or switch positions for mixing. Mm-hmm. And that would have solved things, but we don't have a Dante card because they are unobtainium, as it was said earlier.
Currently. But see, this is an ongoing, this is one of those big difficult things, other than the unobtainium thing. But like the protocols, and it's been forever that you have either like a protocol or a medium or something like that that's created by a company versus being created by a conglomerate of companies or an organization. So we have AES, which is the Audio Engineer Society, and they a lot of times will try to do protocols and the AVB is actually through AES and then through another, like a video society sort of thing. And so they'll try to do those, but the problem is that they're not like making any money off of that, and so they're not always as well supported either. Where you have Dante, which has a company behind it, and it's really well supported, but then it's like the company has to make money, and so they have to have the chips and they have to, make the deals. So anyways, it's always this big issue, and that's what CDs when they first came out was the same thing, and it's like why did it create?
Can I kind of go through a little bit of like a rundown of like some of the benefits and the flexibility of these things? I'm gonna use some networking terms describing these things, but like it's kind of hard when it's all networked audio. The use cases that you would often find networked audio in is like there are instances in like studio applications where you can have essentially individual monitor rigs set up, and you're sending all that information, all that audio information to each person's monitor in a studio by Ethernet, and all you have to do is run one Ethernet cable to each one, essentially from your network switch or hub, and they basically can control their mix completely through like a digital little controller. That's one of the benefits of like RedNet, which uses Dante, which is a Focusrite protocol. Dante protocol, but Focusrite designed to object. Now, there are instances where it can scale, so you can have anything from a small one to a large thing. And like I actually worked with a company recently that had a bunch of essentially networked audio for each drop point for their arena setup of line arrays. They had a bunch of like ground stacked line arrays that were angled up towards the audience seating in the stadium, and they were all just connected with fiber optic Ethernet cable. And so instead of using it as like a sending spot, it's now a receiving spot where they're receiving that audio and then transmitting it through the speakers. And so you have a lot of flexibility in these things where that audio can essentially, if any part of that network is connected, they call it topology is the term that they use in the networking world. As long as it's a part of that topology, you can send essentially any audio to any node on that topology, which is the big flexibility and convenience. Essentially, if you have Ethernet going to that thing and it can make sense of that signal, you have audio there well, and it's not bad audio either. Like I think Dante supports like 64, like 128 channels of like 1644.1 or even up to 96K, I think too. I can't remember.
It's I believe it's 24-bit 48K. It was 64 by 64, and then each time you increase the sample rate, it
decreases the number of channels that you can run.
Yeah, because it's based on the throughput.
But like you can do that with all kinds of things in the studio, out in the live sound world. And there are some people who, like in that instance where they had the different drop points for each of their line arrays pointing up to the audience, they actually were running all their RF, all their wireless microphones, talked about earlier, on Ethernet, basically to an Ethernet switch that connects all of the wireless microphones to this Dante network that they essentially, I don't think it was Dante, I can't remember the protocol, but then they were just controlling it essentially from like one person's laptop that's connected to the network through an Ethernet cable, and they could route all of that audio to anywhere. Wedges, like different line array segments, like, and they could break it up into segments and build groups from those segments, which is the big, like for live sound is a major flexibility that you have, especially with the complex sound setups and stuff like that. So that's one of the big benefits of network audio.
Yeah. And then I'll point out that, I mean, actually right here, what I'm doing right now, like I have a SoundGrid interface. So SoundGrid's another protocol used by Waves and Digico. And so I have a couple SoundGrid interfaces. And so right now I have two computers connected to a single interface. And they're all connected through Ethernet. So I'm running my main computer, and it's running the Zoom that we're recording, and we're recording on my computer. And when I tried to record my audio from my microphone on this same computer, it had trouble trying to do both things at the same time, trying to record the Zoom and record my audio. So I set up a separate computer. So I have a laptop running, connected networked through the interface, and I can send the audio back and forth. So I've got my audio going into the mixer that's for the interface, and then that audio is coming into Zoom, so we can record that as part of the Zoom video and audio thing, and so that everybody can hear it as we're working on this. But then the audio is also going to the other computer through, and so there's three things on the network, two computers and one interface, and I can send audio all over the place with that. So it's pretty crazy. It gets a little confusing when you're trying to set it up, because like I had one point where I was trying to set up the two computers for the first time, and I kept trying to do it this one way that seemed like would be logical to me. And then I had to think, how would a network engineer do this? And so then I tried something different, and I'm like, okay, this is not what I would have tried as an audio engineer, but this is what I would try and that's what worked. But like, you have to kind of think of how, these folks, when they were,
you have to realize too that like the way that you think of signal and how signal transfers and how routing works in the audio in an analog world does not work the same way in networked audio. Yeah. Like I refer to the term topology. I've taken networking courses, so that's why I'm a nerd about this.
He was a nerd before he took.
Don't listen to Ben. He doesn't know anything about me. You don't know me. No. So there's a couple different ways of looking at the topology for these networked audio. There is the physical topology, which is literally the physical connections. So things like plugging your Ethernet into a network switch and then connecting that to a router, and then connecting that to like a mixer or to a microphone thing, like a transmitter receiver, right? There's that. There's the physical topology, the physical connections, which is different from analog because the physical connection and the signal connection follow the same path. They are the same thing in analog. In digital, it's not. You have the physical topology and you have the logical topology is the term that they use, which is how you route things through the Ethernet network. So like Ben was talking about how all of these different parts and pieces are communicating together, and they're all essentially running as individual computers. Think of each connection in this chain as a computer that has its own autonomy to do essentially its own thing in the audio network. Or even thinking about roadways that are going back and forth between these things. You can have something stop off here at the mixer and then drop off some more audio over here at the monitor, and then you can have it drop it off at another monitor. And they don't have to necessarily be, they can be essentially Ethernet networked together. I know TurboSound actually does that with a lot of their speakers. They can do like Ethernet and stuff. Yeah. And I mean, even Behringer has it with like their P16s.
Well,
there's AES50, and then they have their own like monitoring system that's Ethernet too.
The P16,
Yeah, P16, yeah.
And like another use case is like running a bunch of backing tracks. Some people will have more, 8+ backing tracks that they're wanting to get to, like a console to be able to back them up as they play. So if you have like 16 channels, it's super easy to do that through Dante. You can just use Dante Virtual Sound Card, come out with like single Ethernet cable and go into individual channels onto some other Dante, some console that has Dante, like the Allen and Heath stuff or the like Yamaha series stuff. And then you have just that one cable that is connecting it all with the part of that Dante network.
So yeah, I did have an epiphany as we were talking about, as Joe was talking about the topology and stuff. Another thing that I think is important to bring up that gets confusing is whether you're doing discrete point-to-point or you're going through a switch or a router. Because a lot of these things, like right now with my setup with the two computers connected to the single interface, the interface has a switch built into it. And so it has like 5 Ethernet jacks on it. And so
it's probably more like a router, but yes, you can call it a switch, I guess.
It says in the manual it's a switch, but it is a router. I mean, they call it a gigabit switch,
Oh, that's different.
Yeah.
That just means it's rated for gigabit. Anyways, keep going, whatever.
Yeah. He's going to just everything I try to say.
This is my realm.
But see, then you've got like the consoles we've been talking about, and then they'll have their stage boxes. And a lot of those need to be point-to-point. So it needs to be from the output of the console directly to that box. And if you try to run that through some kind of switch or
router, as the Brits would say,
it's not gonna work. There's going to be problems. And like theoretically, you could run that over a Wi-Fi thing too, but a lot of these protocols do not.
Wi-Fi is not consistent enough to maintain strong signal quality.
But it's not
interference.
It's not like you can just plug your board into the internet over like a regular router, and then just be able to control, whatever. Like you go down to the bottom of the stage and you connect that to the internet too, and it's like, oh, I'm just going to dial this up on the internet.
But didn't you literally have somebody like jank with you, like through the internet, like mess with your mixer?
Yeah, but that
was
was
over the internet.
That's
to your X32
that was through the control. So like, there's two different things. Like on the mixer, you can send to your stage boxes and the communication. So like, you look on the back of some of these mixers, and there's like 4 different Ethernet ports, and you're like, well, which one do I connect to? So there's the ones that are like signal communication, but then there's other ones that are control. Yeah. And so so I had this. I was working on a Midas M32, and this guy had plugged the control port. Usually, you just plug the control port into a router,
like a local network,
and you create a local
to
network.
The internet.
Yeah. So you're just creating. But he'd actually plugged it into the wall and set it up so he could dial it up on the internet. And so then, I mean, he did it for the reason he could be at home and he could have somebody get on, like be having problems on the console, and he could actually dial up the console from home and go adjust things, But he kind of got in trouble because he had like problems with feedback and not doing a very good job because he really wasn't a very good sound engineer. He was really good at setting stuff up like that. But so anyways, so we were in kind of saving the day, and he started messing with our mix. So he kept on messing with the console while we were trying to do the show. And finally we realized what was happening, and so we unplugged it from the wall. And then I'd come back to do a show and stuff, and it would plug back into the wall. So the first thing I would do is unplug the Ethernet cable from the wall, so there was no chance he could sabotage my setup.
Oh man.
My gosh.
So okay, I want to close out with one other thing, and it's about networked for like systems and tuning. So like we've talked about it from like a whole system perspective, but a lot of like modern sound systems, and I'm talking about like the kind of proprietary systems like Myers, D&B Audio Technic, L-Acoustics, things like that, where they're high-end systems that are like designed a certain way. So we've talked about just sending audio from one location to another, and we talked about control. I'm going to take control a little bit further to like DSP for system tuning. So I've recently been looking at some new speakers for my work, because the ones we have are old to the point where I can't actually update my amp racks. I can't actually update or use the network systems because they're no longer manufactured. And I've been looking at newer, more modern options. And one of those issues that you run into, especially with a DSP, is, so let's say you can network all of your amp racks together and manage all of your amp control, including like volume gain, yeah, same thing, whatever. Equalization, delay, even for like things like outfills, side fills, satellites, all of that stuff. And like, you know, satellite towers and like delay towers and stuff like that. You can manage those things from like a single network. I know that some of the modern JBL stuff, which is one of the things I've been considering lately, has not so proprietary of a network. So the cool thing about these is you can network all your speakers or your amp racks together and then control all of the processing for those for a systems tuning perspective. So things like like I just said, equals. I'm not going through the list. You know what I mean.
You can control gain, volume, amplitude, level,
loudness, SPLs, all of it with one knob. No.
Moving that fader up and down.
You can even play Pong on some of these amps, actually. Like I've done that on my amp racks. But no, so that's one of those things that like you have a lot of benefits. And the cool thing is you can walk around with like an iPad and essentially tune your system from that. Now the cooler thing is a lot of these like fancier things like the L-Acoustics rigs and some of these other things, and even some of them that don't, for line arrays and larger system arrays, they actually have tuning systems where you can do like, they'll do like modern CAD drawings of the venue that they're going to, and then they'll input that into software, and the software will give you the exact hangs. Likewise, it'll give you DSP calculations for that space based off of both an RTA mic and the CAD drawings that you've put into the software that is running the DSP. And so a lot of like the tunings part of the system tuning can be done for you through these types of networked audio with things like RTA and CAD drawings for these audio systems, which is really nice and really convenient. And if you know how to make it work, it can do a lot for you.
Yeah. If you got all that. No, but it's pretty cool. Like, it's pretty insane, like the control that can be done. But yeah, just to sum up, all of it is, like Joe said, each device really is like a separate computer that's kind of functioning and communicating with everything else and saying, oh, we're going to bring information in and send information back out. And the cool thing is, if they're all on these nodes on the network, they can all communicate every single direction. And so like, yeah, you can have every speaker that's in your line array is one of those nodes on the network being communicated with.
Super nice.
Yeah.
Cool.
With that being said, I'll say one last thing. We're barely catching up to lighting in the real world. Thank you. Come again. Mix good.
Mix good.
Mix good, I guess.